Something just arrived in our sky that forces a terrible, simple choice. Either rewrite the rules of physics, or admit something engineered has entered our solar system. This object, nicknamed Atlas, didn't just show up. It behaved in ways our textbooks refused to accept. Images from orbit made researchers rewind their footage. Measurements hint at a metal signature you'd only expect from factories on Earth, and its speed changed without the smoke and gas physics says should be there. Put those pieces together and you hit a fork. Expand everything we think we know about comets, or face the possibility we're looking at technology that didn't originate here. In the next few minutes I'll show you the images, the numbers, and the single test that will force the science world to pick a side. But that wasn't the whole story. It started as a routine alert, a fast-moving blip flagged by the Atlas survey, but within hours every major observatory had pivoted to the same patch of sky. What made people take notice was simple. The orbit didn't match anything born here. It pointed back beyond our system, which is something that has only happened a handful of times. Teams rushed to trade images and spectra, and the chatter moved from interesting to urgent. Instruments that usually operate on long timelines were given priority slots, and small observatories found themselves on the same feeds as space telescopes. The mood went from curiosity to tense focus, because the first pictures and numbers already disagreed with everything we expected to see. But that wasn't the whole story. The first real shock came when a Mars-orbiting probe turned its camera toward Atlas. Even in low resolution, something was off. The core looked too bright, too compact, and the light it reflected leaned toward a deep, unnatural blue, the kind you should never see on a cold chunk of ice. When those frames were lined up in sequence, faint side structures appeared, like rigid edges instead of the soft melting glow of a normal comet. That alone would have sparked debates, but then ground telescopes and JWST added their own strange details. Some images showed a tail, others barely showed one at all, and the surface seemed to reflect light in patterns that didn't match dust or frozen gas. Astronomers who have seen thousands of comets said the same quiet thing. This isn't behaving like it should. And if the photos caused unease, the chemical fingerprints that came next turned unease into alarm. When scientists broke Atlas's light into a spectrum, they expected the usual comet recipe: ice, dust, carbon compounds, and the familiar pairing of iron and nickel. But that's not what showed up. Instead, the signature leaned heavily toward nickel, and strangely light on iron. In nature, those two travel together, born in stars, scattered through space and fused into planets and comets side by side. Separating them takes something else entirely. On Earth, it requires massive energy, controlled temperatures, and industrial refining. That's why this result shook people. It suggested a level of chemical purity that comets simply don't have. And more surprises kept stacking up. Atlas didn't appear to carry much water, even though comets are famously dirty snowballs. This one looked closer to a polished metal fragment than a frozen wanderer. At first, some scientists tried to explain it as contamination or a measurement error. But then the motion data came in, and that's where the theories started to break. Comets don't just drift. They push themselves forward by venting gas, like tiny natural rockets. When sunlight heats the ice, vapor shoots out and the object nudges in the opposite direction. It's predictable, measurable, and it always comes with a bright, dusty cloud. But Atlas refused to play by those rules. Instruments recorded a clear acceleration, a real change in speed and direction. Yet the sky stayed clean. No giant plume, no storm of dust, no spreading cloud big enough to explain the thrust. If physics is right, Atlas should have shed billions of tons of material to move the way it did. That kind of cosmic explosion would have lit up telescopes around the world. Instead, it was like watching a rocket fire. Without the flames, scientists ran the math again and again, and the answer never changed. The push was real, but the exhaust was missing. When a natural comet breaks the rules of motion, you only get two explanations. Either our physics is incomplete, or something is pushing it with a method we've never seen before. And if the motion was strange, the timing made it even stranger. If Atlas were just a weirdly dry comet with a strange metal signature, an impossible acceleration, that would already be enough to make astronomers nervous. But the sky had another twist waiting. When scientists plotted its path forward and backward, the numbers landed on something far more unsettling. A sequence of planetary encounters that looked almost intentional. Instead of wandering randomly, Atlas threaded near Mars, skirted close to Venus, and angled inward on a line that gave it perfect gravitational assists. The kind of optimized route you'd calculate, not stumble into. Even veteran orbital analysts hesitated. They ran the probability of a natural object hitting those key flybys in that exact order, at that exact timing, without drifting off course. The numbers came back painfully small. Not impossible, but so unlikely that people started whispering privately what they wouldn't dare say publicly. And then came the coincidence that made even skeptics uncomfortable. The inbound direction of Atlas pointed toward the same slice of sky associated with a famous unexplained radio signal from decades ago, the one that's still argued about in textbooks. Astronomers spend their lives warning the public not to jump to conclusions, and yet here they were, staring at overlapping oddities, engineered-looking metals, missing exhaust, impossible acceleration, a precise planetary tour, and now this directional match with a signal we still can't fully explain. Of course, coincidences happen in science, but when coincidences start piling up on top of physical anomalies, something changes. You stop asking, how do we explain one weird detail, and start asking, how do we explain all of them at the same time? Some researchers insist there must be a natural explanation hiding in the data, something we haven't found yet. Others argue that science has always advanced when someone dared to question the comfortable answer. And at the centre of this fight sits a simple, brutal test that is now only weeks away. Only because if Atlas really accelerated without losing mass, physics demands one thing. A missing cloud is impossible, and that's exactly what scientists are about to check. Every telescope operator, every observatory schedule, every instrument that can lock onto Atlas is waiting for the same window, mid-December. It's not about taking pretty pictures or measuring its brightness. It's about searching for the truth. Physics says we should already see a massive cloud of gas and dust. If Atlas behaved like a comet, that cloud must exist. Not maybe, not possibly. It must be there because the numbers require it. For Atlas to move the way it did, it should have blown off billions of tons of material. Even a small fraction of that would create a coma so enormous that telescopes wouldn't need to hunt for it. They'd trip over it. So here's the test. Either the cloud shows up or it doesn't. And whichever answer we get will shake the scientific world. If the cloud appears, then we've found the strangest comet in human history. One so extreme that it forces textbooks to be rewritten. We'll have to ask why it looks metallic, why it's so dry, and why its surface behaves nothing like frozen dust. That alone would be a milestone discovery. But if the cloud doesn't appear, if the telescopes stare directly at Atlas and find empty space, then every conservative explanation collapses. There's no equation left to hide behind, no convenient comet physics to fall back on. Without that cloud, only two possibilities remain. Our understanding of motion and mass loss in space is wrong, meaning physics itself needs a rewrite, or Atlas is moving with a propulsion method that does not come from nature. Either answer is historic. Either answer changes everything we believe about what can move through the solar system. And the best part? We don't have to wait decades or years for clarity. We get the answer in a matter of weeks. So as December approaches, scientists aren't just watching, they're bracing. Because one object, smaller than a city, may be about to prove that we're not the only ones capable of building something that crosses the stars. So here's where we stand. Atlas isn't just another frozen traveller passing through the dark. It's a puzzle wrapped in more questions than answers. Metal where ice should be, motion without the exhaust physics demands, and a trajectory that reads more like a plotted course than a random stumble. Even the most traditional scientists admit that something about this object refuses to fit inside the comfortable box of just another comet. But the remarkable part is what happens next. For the first time, we won't be guessing in the dark. The telescopes are ready, the instruments are tuned, and the moment of truth is locked in. If Atlas left the kind of debris cloud its acceleration requires, we'll see it. And if the sky stays empty, the silence will speak louder than any headline ever could. Because that would mean one of two things. Either the laws of motion need an upgrade, or someone, somewhere, built this thing. Either answer changes what it means to look up at the night sky. So keep watching. I'll be breaking down the data as soon as it drops. What the telescopes find, what scientists say, and what this mystery turns into next. Until then, tell me what you think in the comments. Are we looking at a new chapter of physics? Or the first confirmed visitor that didn't come from nature? And make sure you're subscribed. December might be the month we realize we've never been alone.